Hello, everyone.
Hello.
Welcome to Arduino EDUvision episode 6.
Oh, already 6. That's
Yes.
nice.
Today we're talking about the importance of learning coding at an early age.
Yeah, with our special guest.
Yes. I'm Melissa.
I'm Roxana. Hello, everyone. Thank you for joining. So, as usual, let us know where are you from. If you're a teacher, student, parent. So, from where are you joining? We want to know all of that.
Hi, everyone.
Hello.
Nice to see people joining.
Yeah, it's really cool. Thank you all for joining. So, Melissa, could you please tell us what are we going to have again today?
Yes.
Yes.
Nice. So today we will talk about the importance of learning coding and computational thinking at an early age with our special guest, Marina Umaschi Bers. She's a researcher and professor at Tufts University.
Yeah.
We will also have a live demo. I will show
Ooh.
you one of the projects. Yes, this one. I created a small town, and this
That's
is
so
based
cool.
on one of the projects from Student Kit. So we're going to show you how to create this and how you can do it with your children or with your students at home or at school
Yeah,
with the help of the Student Kit. And of course, we have our Edu Spotlight today.
exactly. So stay tuned. Don't go anywhere, guys. We want to see you also. If you have questions for our guest or any questions during Melissa's demo, please feel free to write it on the chat.
Yes. There's someone from Finland. Yes. Go Finland.
Woo! Finally. Good. Peter. Do you pronounce it right that like in Finland, Peter?
Yeah, I would say Peter, but yeah, Peter is not really a Finnish name.
Okay. So hello. Nice. Algeria, Greece, India. Nice. Vancouver. That's so cool.
Great.
Nice. So happy to see you all joining today. Netherlands. Cool. Just let us keep writing where you're from, guys.
Yes.
Nice.
Rox, would you like to introduce our today's guest?
Of course, as Melissa said before, we're going to have Marina Bers. She's a professor at Tufts University, but she's also a researcher. And she has been awarded with a lot of, or she had a lot of recognitions during her career. She has wrote a book. Let me show you. Here. So she wrote this book, Coding as a Playground, and now the second edition of her book just came out. So we're going to talk also about her with this. And currently, her research is more focused on children, on their computational thinking development on children from 4 to 7 years. So we're going to ask her a lot about her research and her project. So everyone, let's welcome, please, Marina Bers.
Hi, everyone.
Hello, Marina. Good
Hello.
afternoon.
Hello. Nice to see you.
Nice. He's joining from the US, specifically in Boston.
Mm-hmm.
Hi,
Yes.
Marina.
Hi.
And during
Hello.
our discussion, if you have any questions for Marina, please use the chat on Facebook and YouTube.
Yes. Take advantage of this opportunity because Marina has done a lot of things researching with this topic, which is very important. So please ask her questions.
Yes.
So why don't we start with the first one?
Yes, we can start with the first one. So if you could explain us, what do you mean coding as a playground?
Yeah, so if we think about best learning places, the best learning places happen when children are collaborating, where they are discovering, where they are imagining, and when they have autonomy. So if you think of a playground, parents are usually, or teachers are sitting on the benches, and the children are doing it all. They are engaging, they are talking, and the parents only intervene there's a big safety issue, right? So when we imagine bringing coding or robotics into the classroom, that's the kind of experience we want. We are in child development, we say that all domains of human development can be found in the playground. You have language development, children are talking. You have social development, children are learning how to collaborate, how to solve conflicts. You have emotional development, children, struggle and they have emotions and they cry and they laugh and they need to learn how to manage their emotions. And of course, you have cognitive development, learning new things, discovering, and of course, physical development. They are doing things. They're not just sitting in front of the computer. And so when we think about coding, really for all ages, but especially for early childhood, we want to have experiences that look like a playground, and robotics is great for that.
Yeah. What about if we take a look at some of the videos that you share with us about some children playing with some robots? So let's take a look.
Yeah, so what you're going to see right now is, so in my lab, we develop a robot that's called Kibo. That's for younger children to learn how to code and who learn robotics without needing screens. And so what you're going to see is that they create their own characters and they can add materials on top, arts and crafts. And what you see there in the back is wooden blocks, and that's your programming language. So you have wooden blocks that you program, and the robot has a scanner right there. The girl touched it. And here's a different classroom. This is a classroom in China, and you see the process of scanning.
Yeah.
These kids are scanning one by one the blocks. That's how you get your command. And then they're dancing around, and the activities, they were programming the robot to dance the hokey pokey, and then they were dancing alongside.
That's so cool.
So you can see there, I see that there's a question about emotional development.
Yes.
When you work with robots or coding or computer science, it's hard, right? We talk about it hard fun. And when things are hard, we can give up, or we can keep trying. And if we want to keep trying, we need to learn how to manage our emotions, and the younger we are, the harder it is to know how not to be frustrated, to understand that we have to explore multiple strategies, not just to give up. And all of that is part of emotional development. And when we work with young kids, this is not just something that happens, right? We need to build it into the curriculum and build it to the experience, because young kids naturally are not, they're not ready. You'll see kids throwing tantrums on the supermarket. That's because they don't need how to deal with their emotions. And it's part of growing up. And robotics provides a great opportunity to working with those, because kids are very motivated when they're working on a project they really want to create and they really want to see out. So it's an opportunity.
Nice.
And then I was thinking, you also mentioned before that coding as another language. So you also mentioned that the playground, you have they're learning language, they're talking to each other, but then you have this research about coding as another language.
Right. So, we usually think of coding as associated with STEM or STEAM, science, technology, engineering, and math. However, that's the very small fraction of how coding can be used for, or robotics or computational thinking. Because if you think about it, coding is learning how to think in new ways, in abstract ways, in logical ways, in sequencing ways, logical problem solving, right? But before we actually learned the language of computers, it's just that we forgot, when we were learning how to talk on our own natural languages, we also were exploring sequencing, what comes first, the verb, the subject, and noun. We were learning language and using language, because written language is a symbolic system of representation, and that doesn't come naturally. What comes naturally is talking. But we had to learn an artificial system of representation in order to learn how to use reading and writing. So the same thing is for coding. Different languages have their own systems of representation with their own syntax and grammar. But the most important thing is the thinking that happens before the language, right? If I know how to think, then I will learn a language to be able to put that thinking into action. And that, I think, is when we talk about coding as a language, that's what we mean. And our approach for teaching young children is we teach them as if they were learning a new language. And the goal is that once you know a language, you can use it for anything. You can use it for math, science, technology, engineering, STEM, but you can also use it for social science, for geometry, for literacy, for anything you want. And so we believe that it's a missed opportunity if we're just limiting coding to STEM disciplines. It's like reading and writing. It's for everything else we do in life, and also for building future citizens, because democracy, we want people who are critical readers and critical people who can understand the world around them. So that's what it means. Understanding coding as language really opens up to a thinking individual.
Yeah. We have another question. But then why did you decide to start a research with these like super small kids? Why is so important to teach these small kids at a very early age to start to this computational thinking? Why so young?
Yeah, so what happens is, if you think the age we chose is the age that in general literacy is taught, not in every country, but more or less, between 4 and 7, in most countries, children are taught how to read and write, because that's time where you develop literacy. And there's a big problem. There's tons of research that shows that by 4th grade, meaning around 8 or 9 years old, if you didn't get into math or technology or engineering before, you're going to have stereotypes. And you're going to start thinking, I'm not good at math, I'm not good at science, it's not for me. And at least the research in the US, I don't know all over the world, but in the US, it shows that it's mostly the girls and the minorities who are going to say, this is not for me. Well, if we start early, when they're 4, when they're 5, those stereotypes don't exist. They're ready, they're curious, they're sponges, they want to try everything. And they're used to playing with everything and discovering anything. So let's give them one more language, the language of computers, the language of robotics, so they can actually discover the world through those objects as well.
Yeah.
Yeah, I really like that. You give the same kind of chance for everyone to be interested in computer science or technology or whatever topic it is, but you have the same start point for everyone. Yeah.
And it's also interesting because sometimes maybe people think that when you learn how to code and programming, it's also because you're interested in engineering or computer science, but it goes beyond that, right? When you learn these skills.
Right. So for us, learning to code, like language, it's a way to express ourselves. So when I learn so I'm originally from Argentina. When I learned my second language, English, to come to the US, I only knew that I really, really know the language when I was able to enjoy a book or write a poem or write my story, not when I passed the test. That was just passing a test, right? The true knowledge of fluency came when I was able to use the language to express, to create, to make something that I deeply care to share with others. And the same thing is true for coding. You might be able to pass a test, but that doesn't mean that you really appropriated the coding language to be able to make something that you really care about. So in our approach, that's also very important when we say coding as a playground, coding as a second language is, well, own the language, learn the fluency, develop that fluency, and then make a project that you really care about. And the better if that project can be shared with others, because language is about interpersonal relationships. And we sometimes forget that coding is also about interpersonal relationships, because when I'm coding with others. I'm not just coding alone. In the cultures of coding today, people help each other. People post, people ask. It's not anymore the nerd in the basement. That's a wrong stereotype. And that's another aspect where socio-emotional comes into play, right? Socio-emotional development. Coding is an activity that's done in communities, like language.
Yeah, that's very interesting and enlightening. So what can you say to teachers or even parents that they're not sure if their small children should getting started learning because they think they're too young? Or how can they start also probably now at home teaching them
Kind of
skills?
where they should start or what they should do.
So I, of course, will recommend my own research, which is specifically for these kids. And so we developed 2 different programming languages. One is Scratch Junior, which is free. And you can download it on Android or on tablets and iPad, scratchjunior.org. We have 32 million children all over the world. So, and we have developed curriculum. And if anyone is interested in looking at curriculum, it's all posted. And we have a curriculum that's also called Coding as Another Language, or you can go into my website and find it. That's for Scratch Junior, which is on tablet. Some parents don't want young children in front of tablets. And so for those parents, we have the keyboard robot. which you have to get, and it's a physical, which we saw in the video. It's wooden blocks you put together, no screens, no keyboards. Your keyboard has like the supermarket, like you can scan the blocks, and you bring your own arts and crafts. And so those are, and we also have lots of curriculum for keyboard robots. And what's actually very interesting, I think this audience will like to know, is that our first prototypes with keyboard were done with Arduino before keyboard was an actual that before you could buy Kibo, when it was just a research lab. So right now, Kibo, it's the company that we launched that's called Kinder Lab Robotics, and you can go there and get your Kibo. There are different kinds for different ages, but I'd say 4 years old is the right age to start. But of course, to start with the coding as a playground metaphor. Where children are going to be playing, discovering, expressing. It's not about efficiency. It's not about product. It's about the process of learning and having fun with it.
There was actually question about like what if children spending a lot of time with the computers, but it's not just spending time in front of a computer when we talk about coding or learning about computational thinking. It's right. a lot other things too.
And I think it's important to understand what is a young age, because a 4-year-old is very different than a 10-year-old. So for example, for my own PhD, I did at MIT at the Media Lab, and we work a lot with Lego. Those Lego kids are great when you're 8 and up. But if you're younger than that you don't know how to read and write, and you have very small fine control, it's not easy, and then kids might get frustrated. So I think it's really important for all of us who are working with robotics to really understand that not all kids are the same, right? The needs of a 4-year-old is different than the needs of a 7 or an 8 or a 10 or a 14-year-old. So I think it's really very important to really understand the technologies, because if we expose a very young kid, and very young, I mean a 4-year-old, to a technology that was developed for an older child, you might get exactly the opposite of what you're looking for. Not interested. The parent might be really interested, but not the child.
Being overwhelmed or frustrated, or then just bored. It doesn't find it interesting. That's a good point.
Right. So I think it's really important to understand that children's ages matter.
Yeah, for sure.
Just like in the playground, you have different playgrounds for different ages.
Exactly.
You know, I know where I live in the US, we have the 3-year-old playground looks different than the 5-year-old playground, and very different than the 10-year-old playground. So it's the same with technologies. And I think we need to really be aware of those developmental differences.
Yeah,
for sure.
Exactly. I agree. And then, then you apply the rules from the smaller playground to the next one, and to the next one. You go kind of from the stage to another, and you learn. So I think that's also a nice metaphor.
Yeah.
And that's important, because sometimes, because you want to teach small kids how to code in a programming, then you give them the wrong tool, right? And then instead of helping, they get frustrated, and then you don't know how to do to keep them engaged if the tool is not designed appropriately for them, for the cognitive development. So that's
right. And it's about the tool and the curriculum. It might be an informal curriculum, but they really need to be developed with an understanding of what are children able to do at different stages of development.
So Marina, what are you doing next? Are you researching something else, something different? You stick to 4 to 7 years?
Yeah, so I love that age, 4 to 7, first because there's very little in terms of technologies for those children, and it's so fundamental. You know that a research done by Nobel laureate of economy has shown that if a country wants to invest in education, they need to start in early childhood, because if you start late, you're doing remedial. You really want to change a culture, change a country, you need to start early. And so I love that age, and I think it's fascinating. It's also technically challenging, because it's a lot easier to design a system for engineers or people that can read and write than it is for kids who are just learning. So right now, all of my research is, we have just launched this curriculum, Coding as Another Language, and we are trying to find partners. We're working in different countries. So if anyone is interested, send me an email. We might think for both with Scratch Junior and Kibo, to do research on, young children, but how is it really happening that you learn coding as another language? And how can children can move up their stages of cognitive development through coding and with coding? So that's what we're really looking at right now with both Scratch Junior and Kibo, to see how these can be taken all over the world. We want to conquer the world, basically. We want every 4 and 7-year-old to learn coding, because if we believe in democracy and we believe that critical thinking is important, which we need all over the world, this is a great way to start. If you think about logical thinking was back the Greeks, democracy was started back in Greece, where they were learning in philosophy. Philosophy was logical thinking. Now we have a new kind of philosophy, which is programming. Well, but the goal should be really to have better societies and better individuals, not just better jobs.
Yeah,
of course, we're gonna get a better job if you know, if you have the technical skills, but that's not my goal. My goal is really to educate every child so they can learn how to think in new ways, and their thinking will be for everything and not just for technical space.
Yes.
Great.
Thank you. Agree.
Yeah.
Thank you for the interview.
Thank you, Marina. Yes, and remember, if you want to read Marina's book, it's Coding as a Playground, and she also has some articles on her website, so go and check that. It's very interesting.
Yeah, and you can visit our remote learning site, arduino.cc/remote learning. There's an article about Marina.
Marina. Yes. Thank you so much, Marina.
Bye.
Thank you. See you.
Thank you. Bye.
Bye.
That was so interesting.
Yes. And a lot of great questions in the chat. Thank you.
Yes, thank you
for all
so
of
much.
you who asked questions. Unfortunately, we can't always answer all of them, but hopefully most of them we managed to answer.
Yep.
And then, so if you want to read more about Marina, you can go to our remote learning site, or you can check her book. The second edition is out now. It was, from last week.
Exactly.
And then should we watch our Edu Spotlight?
Let's take a look.
Computational thinking is the thought process involved in formulating a problem and expressing its solution in such a way that a computer, human, or machine can effectively carry it out. The skill focuses on critical and logical thinking. In other words, it's a problem-solving skill. Computational thinking involves 4 steps. Step 1 is the composition. That is the action of breaking down a complex problem down into smaller, more manageable parts. Step 2 is pattern recognition, which is the action of identifying patterns or trends within a problem. Step 3 is abstraction, which suggests identifying specific similarities and differences among similar problems to work towards a solution. The 4th and final step is algorithm design or thinking, which involves developing step-by-step instructions for solving the problem that one can use to solve similar problems. But why is computational thinking so important? With our society's increased reliance on digitation, it is even more important to understand the concepts behind understanding and communicating with technology.
Thank you, Pablo.
Thank you.
There's some info about computational thinking.
Yeah.
And today's, I think we can also have our discount code.
Yes,
so
let's show
today it's traffic lights.
And it's for?
It's 10 euros for the student kit.
Yes.
And for the next 24 hours, you can use this code traffic lights on our store to get 10 euros from the student kit. And actually next we're gonna tell you, if you don't know what is the student kit, we're gonna explain a bit what it is and
what
show
you can
the
do.
demo. Yep.
Exactly. So exactly, Marina, if you remember, she was talking about designing and having the right tools for the right age of children, right? So you don't want to give a 4-year-old a tool design for an 11 or 12-year-old. So then the student kit was designed or having in mind children from 11 up. So we have this kit with all the components, basic electronic components to build 11 lessons. We have an online platform. We have explanation step by step. They have the code there. They need to type. So they also develop this ability to type and read code. Very important. So Melissa is going to show you a demo. We're going to share with you the platform, the content, so you see how is the design, the kind of information we have there for these young children to start from zero, how to learn coding and programming and electronics in a hands-on, fun way. So
yes. I can show a bit of the
the platform.
So here, this is one of the lessons. It's called the traffic signals, and one part of the lesson is about traffic light with pedestrian button, and that is what I created also today for you guys to see. And it comes with all the materials that you need for the lessons and for the projects you have in the physical kit.
Yeah,
and then you follow the wiring, the step-by-step for the wiring. You can find here how to add one wire at a time. You know how to add all of the lights for the traffic lights, how to add the button. And then, for example, there is a flow chart explaining how the conditional statement works, how if else works, and everything like that. So everything is really step by step. Everything's explained, and also has these great examples from real world, like the invention spotlight, where it explains how traffic lights were invented. And I can show the project that I have here.
Yes, let's take a look.
Yes, let me turn my camera.
So you will see that, yes, there is. Okay, let's show that in
here. So you can all see this is, so I created the traffic lights, and that's based on the project. So you can see in the project or in the lesson, you just wire using the breadboard, but then after that, you can do whatever you want. You can create this small town with all different cars and different traffic lights, and you get to actually use your project in practice. So here, for example, I press the pedestrian button here, and the light gets green for this. So this car is allowed to go now. Oh no, now they have red. And then here they have a green again. So these can go. This person forgot to go to the other side. So then it could press here again. And the idea is that when I press this light will go red and this one will start. So this one will have green. And then after 5 seconds or 3 seconds, whatever you want in the code, it goes back to the red one, and these people can go again and have the green. So it can seem really simple. You learn a lot, but then you also get to build around it. So it's not just how to create the program or how to do the wiring, but it's also what you can do afterwards with it. And you can have this crafting, or you can play around with it. You can modify it the way you want. You can build 50 different traffic lights if you want, for example. I'm back here.
Really interesting because also, one is saying that he loves Arduino. Nice. Oh, won a contest of Arduino project. That's really cool.
So and if you have made a lot of interesting projects, please share them with us. Yeah, you can use social media, or you can use the remote learning site, for example. There we have our contact form, so you can send projects through that too. So we would love to see your projects.
Yeah. You can also use the traffic lights now that we are at home. If you want, for example, your parents to go to your room, just press the red light if you don't want them go in, or the green one if you want to let them in.
Yeah,
so
exactly.
Many applications, right?
Yeah, there's different ways to use it's not just traffic lights that you can do with LEDs and buttons. There's multiple different things that you can
That's the cool thing, that you learn the basics and then you can apply it whatever you want. So it's really nice.
Yeah. And then there's a question, if you have the hardware that comes with the kit, can you get access to the course content only? I'm not sure what you mean with the only. You can, when you buy this kit, you get the access to the content. So you get all those different lessons and projects. And of course, you can use the hardware with other projects too, and other lessons if you want to, or if you want to go, for example, to Project Hub or find some other interesting projects from internet, or create your own projects without any step-by-step guidance. You can do that with the same hardware. And
Exactly.
this kit is also nice because it comes with the multimeter, so you learn how to use that. Yes.
And also the cool thing is like the platform that you saw, it comes in English, Spanish, Italian, and soon in German, right?
Yeah, I think it's today or this week or
Yeah.
really soon that we're going to have it also in the store in German.
Exactly.
So if you want to have in that language, go to the store and buy it.
Yeah, it's a really easy, fun way to start with electronics, coding, and programming. So take a look.
Yes. And remember, if you now got interested in the student kit, you can find it from our store. I can actually
Yes.
show here I have the platform, but then I have it
Store.
here. Yeah,
Yeah,
student
just type student kit. Mm-hmm.
You find it from here. There's Arduino Student Kit. You can find it here. Has all the info. And with the traffic lights code, you get 10 euros for 24 hours. So
yeah, that's really cool. So you can find there, read there all the information related to the kit.
yes.
Great.
And then if you want to buy from your local distributor, you can find the list also from our store or from the remote learning site. Some of our local distributors and educational partners, they also have their local activities or their own lessons, for example, like online webinars where they explain about these things.
Yeah, exactly. So I think that was it.
Yeah, that's
right?
everything
Almost.
for this week. Let's watch a video from our next week's topic. So this is an
Let's watch
interactive
it.
light installation called Wishing Well. So next week we will have Barbara and Mar.
Yeah, they are two visual artists that use technology in their artwork. So it's very interesting. So we want to show you more of this. So
Definitely,
we wait for you next week.
They're going to have a live project, a demo of their project for us. And we can see some other videos from them. And they're going to talk about using Arduino and arts.
Yeah, it's really interesting.
Arts. Yeah.
Yeah, so don't miss that episode next week, next Thursday at 5 p.m.
Thank you all for joining the discussion in the chat and see you next week.
Thank you.
Bye.
Have a nice day. Bye.